In the last lecture, I explained what is a binary number system, as well as what is a decimal number system, and what is the significance of both binary and decimal number systems, and also what is the base of both the number system, the binary and the decimal number system. So in today's lecture, or in today's lesson, I'll give you a brief explanation of what exactly are the other two number systems. We know that there are four number systems when it comes to the computers or any computer-based applications. So what are the four number systems? We've seen what are the four number systems in the very first introductory lesson, introduction to number systems, where I gave you a clear insight of what exactly are the four number systems, and out of which we have finished the first two, which are the binary and the decimal number system. So what are the other two? Of course, octal number system and hexadecimal number system. So in today's lecture, I will give you a brief insight about the other two, the third and fourth number systems, which are octal number system and hexadecimal number system. So starting off with the octal number system, as you can see, the octal number system uses 8 symbols, 8 unique, distinct. Well, the octal number system uses 8 unique symbols, or you can also call these symbols as digits, which you have been addressing over the past few days. So the octal number system contains 8 unique symbols or digits. And what are these 8 unique symbols and digits? As you can see, it is 0 to 7. That means it's 0, 1, 2, 3, 4, 5, 6 and 7, of course. So it has 8 distinct symbols, that is 0 to 7. So as it uses 8 distinct or 8 unique digits, what is the base? 8. In case of binary, the binary number system talks about only 2 digits, that is 0 and 1, and hence the base is 2. And when it comes to decimal number system, the decimal number system talks about 0 to 9, which are 10 symbols or 10 digits. So the base is 10. Now when it comes to octal number system, the octal number system talks about 8 distinct symbols, 0 to 7. So what is the base? 8 is the base. And if you see this following table, to represent any of the octal digits in binary or in any other number system, first you need to convert into binary, and then you need to convert into the decimal number system. So it can only take just 3 bits are enough to represent any octal number, as you can see from the table. So once again, how do you calculate an octal number system? Just like how you did for the decimal number system or binary number system. So what did you do? Of course, the position notational rule, the POS rule. So what does the POS rule states? I've told you in the last class, the position of every digit has a weight, which is the power of the base. So in case of octal number system, what is the base? 8. So consider any octal number. The position of every digit in that particular octal number will be what? The weight of it will be the powers of 8. If you see here, from the octal point, if you go to the left, what happens? Everything is a multiple of 8. Yes or no? First is, it is 8 power 0, which is nothing, which is 1's place. Next 8's place. Next 64 place. Next, and so on it goes on. If you go from the octal point to the left, it increases times 8. That means every position to the left from the octal point increases by 8 times. And if you go to the right side from the octal point, what happens? Every position is 1 by 8 times of its present position. Consider an example. 437. 437 is an octal number here. So with 7 being in 1's place and next 3. So 1's place multiplied by, what is the base of the octal number? 8. So 1 multiplied by 8 gives you 8, of course. So the second place will be 8th place. What is the third place? 8 multiplied by another 8. 8 8 64. So and so on it goes on, just like how you did in the decimal number system. So that is all you need to know about the octal number system. And now moving on to the fourth and final number system as a part of your syllabus, which is the hexadecimal number system. Hexadecimal number system also contains its own characteristics. And hexadecimal number system, it contains 16 unique symbols. Just like your binary contains 2, your decimal contains 10, and your octal has 8. Just like that, your hexadecimal number system contains 16 symbols. But the only difference to hexadecimal number system and your other number systems is that your other 3 number system, they only talks about numbers, just numbers. If you take binary as an example, so your binary talks about only 2 numbers or 2 digits, or you can say 2 bits, because 1 and 0 are nothing but bits. So it talks about only 1 and 0. Consider decimal number system. So your decimal number system talks about only digits which are from 0 to 9. There are no any other characters other than 0 to 9. Consider octal, which we have seen earlier. So your octal number talks about only symbols from 0 to 7, total 8. But hexadecimal number system, it contains 16 symbols, which are the combination of numbers and as well as characters. So that is 0 to 9 and A to F. 0 to 9 is 10, A to F is 6. So hexadecimal number system contains 16 symbols, which are a combination of both numbers and alphabets or characters. So that is 0 to F, that is 0 to 9 and A to F. So now what is the base or what is the radix of hexadecimal number system? Exactly, 16 is the base of the hexadecimal number system. And why is it 16? Exactly, because it deals with 16 symbols. Hexadecimal number system can contain only the 16 symbols and nothing more than that. So the table here gives you a clear example or clear idea of what exactly am I talking about. Here if you see, hexadecimal numbers from A to F are a single digit representations of the decimal numbers 10 to 15. And whereas in octal number system, to represent any octal number, how many bits have you used? Only 3. 3 binary bits are used to represent any octal number. Similarly, it requires 4 bits to represent any hexadecimal symbol. And again, the same POS rule will be applicable here. From the hexadecimal point, if you move towards the left, what happens? The position has its own weight, right? Here 0 is the symbol here, and what is its weight? 16 power 0, which is nothing but 1. Something power 0 is always 1. So this is 1's place, and this is 16th place, and this is 16 square, 16 cube, and go on. So if you move from hexadecimal point towards the left, what happens? The weight of every digit, or the positional weight of every digit, is multiples of 16. Similarly, you need not confuse, because it is same with every case. In terms of binary, it is a multiples of 10. In terms of octal number system, it is multiples of 8, because the base is 8. In hexadecimal number system, it is a multiple of 16. So mostly that is all you need to know about the basics of all these 4 number systems. Well, that's it. So what I want you to do is take down the notes of all the 4 number systems clearly with the examples. Whatever the notes I gave, just take it down into your notebook, and I want you to go through your notes, understand the topic, and most importantly, I want you to practice how the positional notational rule applied on binary number system, how the POS rule is applied on decimal, octal, and hexadecimal. Take few examples. Take 5 random binary numbers, work on it. Similarly, take a few examples in decimal number system. Take 5 or 10 decimal numbers, apply position notational rule, practice it. Similarly, octal number system, similarly hexadecimal number system. I want you to practice as much as you can, because unless you practice, you cannot understand what exactly is the positional notational rule. So practice, because most probably tomorrow or the day after there will be an assignment or quiz, whatever, on all these 4 number systems. So I want you to be ready for that assignment or quiz, whatever. So don't waste your time. Take down the notes and go through the notes. Practice. And these number systems, as you are new to this concept, you need to practice a lot. The more you practice, the better you can be at these number systems. And I want you to practice enough, and tomorrow or day after there will be a quiz or an assignment. So go through the entire notes, and also be sure to check for any new updates in the classroom, because I don't want any of you to miss the quiz or miss an assignment. And I hope everyone have gone through all the syllabus copy and all the rules and notes taking pattern and everything, and make sure you follow them. And that's all for this class. Okay, bye.